So first we are going to do multilinear regression. Here we have used a dataset called life expectancy data. This head is used to display the first five rows of the dataset. So these are the outputs got generated. Then here the first extra space from the column name are removed. Then only the required five columns are selected. Missing life expectancy values are removed. Missing numerical values are replaced with their means. So this is the output that's generated. So this shows there are no missing values after reprocessing. So here X contains the independent variable and Y contains the dependent variable. The four independent variables are adult mortality, BMI, GDP, and schooling. The independent variable is the life expectancy. So the output is empty for X and this is for Y. Here, the train underscore test underscore split divides the data into 80% training data and 20% as testing data. Linear regression creates the regression model, and this fit is used to train the model. So the output is generated as these. Here, um, predict is used the predictors uses the trained model and tests the data to calculate the predicted life expectancy. And y underscore test represents the actual value and y pred represents the predicted value. So these are the outputs that's actually generated, that is the y actual and then the y predicted. So these are the outputs that have been generated. So here SSE means sum of squared error. It calculates the total square difference between the actual value and the predicted value. RMSE means root mean square error. It gives the predicted error in the same unit as the target variable. So lower SSE and the RMSE indicates lower prediction error. So output is generated, and here R square is the coefficient of determination. It tells how well the independent variable explains the variation in life expectancy. A value closer to 1 indicates the better fit. Here, scatter creates a scatter plot between the actual and the predicted value. The axis represents actual value and y-axis represents the predicted value. So y-axis predicted, x-axis. This is actually x-axis actual value and y is predicted value. So the output is the scatter plot. So here a new input is given in the order adult mortality, BMI, GDP, and schooling. The train model uses these values to predict life expectancy. So the output predicted life expectancy is 64.4 something. Now we move into logistic regression. Here, prostate underscore cancer or CSP, this dataset is used, and this head is used to represent the first five records of the dataset. Here, the pre-processing is done. Dropna denotes the Dropna removes the missing values. The diagnosis is originally categorical, so it is converted into numerics. So B equal to 0, which represents benign, and M equal to 1, which represents malignant. So the output that's generated in M is zeros and ones. So all useful features and columns are selected as X. Diagnostic result is selected as Y. So the ID column is removed because it is only an identifier and is not useful for prediction. So this is the output. Here, the training data set is divided into 80% for training and 20% for testing. Random state 42 makes the split properly. So output is 80 and 20 for training data set and 20, and this is for 20 input for testing data set. So here the standard scalar is used to normalize the feature. Then a fit underscore transform learns the scaling from the training data and transforms it. Transform applies the same scaling to the test data set. Then logistic regression creates the classification model. Fit is used to train the model and learns the coefficient and intercepts. Output for intercepts and coefficients. And here, predict is used to train the logistic regression model to predict the class of each samples. So 0 means benign and 1 means malignant. So predicted values are benign and malignant accordingly. Here, the confusion matrix compares the actual class and the predicted class. Accuracy tells the overall percentage of correct prediction. Precision tells us how accurate the positive predictions are. Recall tells how many actual positive cases were correctly identified. Reference score combines precision and recall into one measures. So next, this represents the graph, the straight line graph. So predict underscore proba gives the probability of each class. This selects the probability of positive class, which is malignant and not benign. So ROC curve represents the calculate the false positive rate and true positive rate. And this ROC underscore AUC underscore score calculates the AOC score, which is given here 0.5. So a higher AOC generally indicates better class coverage. So output you have got a straight linear line. So here a new sample containing 8 feature value is provided. The sample is scaled using the same standard scalar. Predict gives the predicted class and predict proba gives the probability of both choices. So predicted class is 1, probability is 0. This is the output. Thank you.